Today we're going to look at 5.N.2.4, but before we do that, we need to review place value and decimal place value. So let's take a look at that now.
As that name suggests, it's related to regular place value. So be sure to watch our video about that if you haven't already. In a previous video, we learned how to count using just 10 different digits and number places that represent different size groups. For example, if we needed to count 235 apples, we use different number places for counting by ones, by groups of 10, and by groups of 100. The digit 2 in the hundredths place represents 2 hundredths. The 3 in the tens place represents 3 tens, or 30. And the 5 in the ones place represents 5 ones, or just 5. It's a pretty amazing system if you think about it. It only has 10 digits, but those digits can be reused in different combinations to count any number from 0 all the way to trillions of apples and beyond. But, as amazing as it is, there's just one little problem with our number system so far. What if you don't have a whole apple? In the place value video, we only learned how to count whole amounts, or what we call whole numbers, which is the set of numbers you get if you start with 0 and then count by ones, 1, 2, 3, 4, and so on. But there are things besides whole amounts. It's possible to have just part of something, like just part of an apple. And that means they're in between amounts. You might have 1 apple or 2 apples, but you could also have something in between that, like 1.5 apples. How can the base 10 number system handle situations like that? The answer is decimal places. Decimal places are a way of extending the base 10 number system so that it can represent amounts that are in between whole amounts.
Decimal places are a way of extending the base 10 number system so that it can represent amounts equal to whole amounts, in between whole amounts, solid whole amounts, or completely whole amounts. Which one did he say? In between. So decimals represent in between whole amounts. Good.
Decimal places are just like regular number places, except that instead of using them to count groups, we use them to count parts or fractions of things. To see how the base 10 system is extended with decimal places, let's look at the pattern of number places that we saw in the last video. We started out with a number place for counting things one at a time. And when we hit the limit of counting with it, we used another number place on the left side of it for counting groups of 10. By combining those two number places, we could count from 0 all the way up to 99. But when we needed to count beyond that, we used another number place on the left side of it for counting groups of 100. And when those places were maxed out, we added a place for counting by groups of 1,000, and then by groups of 10,000, and so on. See the pattern? Each time we added a new number place, it was located to the left of the previous one. And each time, it represented groups that were 10 times larger than the previous group. Since the amounts that our number places represent get bigger and bigger as we go to the left, it makes sense that number places for counting smaller amounts, like parts of something that are less than 1, will need to go on the right side of the ones place. That's where the decimal places are found.
True or false? The decimal places are found to the right of the ones place. Very true.
And just like the whole number places can go on forever to the left, counting bigger and bigger groups, the decimal number places can go on forever to the right, counting smaller and smaller parts or fractions. But if number places go on forever in either direction, then how do we know which place is which? If they all look the same, or worse, if they're invisible, then how do we know which digit goes in which place? That's an excellent question. We do have a problem now that number places can extend in both directions. Before, when we had only whole number places that extended in just one direction, to the left, we knew that the place that was furthest to the right was always the ones place. But now, we know that number places can extend in both directions. So we need a new way to tell which place is which. What we need is a point of reference, a place that we always start from. And for that, we use a special symbol called the decimal point, which in the United States looks just like a period. Basically, the decimal point acts as a separator. It separates the number places that are used for counting whole values, which are on the left side of the decimal point, from the number places that are used to count fractional values, which are on the right side of the decimal point.
In America, the decimal point looks like a comma, exclamation point, a question mark, or a period. This one's easy, right? Yeah, a period.
And that's why you don't see a decimal point in every number. If there's no decimal digits in a number, like in the whole number 25, then you don't need to show the decimal point. It's safe to assume that the digit farthest to the right is in the ones place. Of course, you could still show the decimal point if you wanted to, since it's always immediately to the right of the ones place. But if there's no decimal digits, then we don't need to separate them from the whole number digits. If a number does have decimal digits, then we call it a decimal number. And the decimal point helps us quickly recognize which digit is in the ones place. For example, if you see a sequence of digits like this, 1, 2, 6, 0.53, you can tell right away that the digit 6 is in the ones place because it's immediately to the left of the decimal point. That means this 2 is in the tens place, and this 1 is in the hundreds place. Okay, but what about the digits that are to the right of the decimal point? We know that they must be in decimal number places, but what are the names of those decimal number places, and what values do they count? Well, looking back at our number place pattern, we see that each time we move to the left, the new number place counts amounts that are 10 times bigger than the previous place. So, each time we move to the right, that place should count amounts that are 10 times smaller than the previous place. Since the ones place counts by ones, the number place to the right of it should count by amounts that are 10 times smaller than 1. The amount that's 10 times smaller than 1 is called a tenth. It's the amount you get if you take one whole, like one whole apple, and divide it into 10 equal parts, keeping just one of them.
The place value just to the right of the ones place is the what's place. Once, tenths, hundredths, or thousands. Once seems really hard to say, so you know that's not going to be the name of it. Tenths. So it's going to go word-wise, it's going to go bigger. Tenths, hundredths, thousands. You'll still count order, but it's really getting smaller. That's what the TH lets you know.
1/10 is what we call a fraction. And fractions are written using a special notation that has two numbers with a line between them. The number on the bottom tells how many equal parts a whole amount is divided into, and the top number tells you how many of those parts you have. So the fraction 1/10 is written like this: 1 over 10. Getting back to our apple counting example, previously we could only count whole apples. But now that we have a number place for counting tenths, we can count tenths of apples too. We can use the ones place and the tenths place together to count amounts that are in between a whole number of apples. To see how it works, let's start our counting with one whole apple and no tenths. That means that there will be a 1 in the ones place and a 0 in the tenths place. But now, let's start adding tenths to that. For each tenth that we count, we increase the digit in the tenths place by 1. 1/10, 2/10, 3/10, 4, 5. Let's pause for a second to notice something important. Do you see that having 5/10 of an apple is the same as having 1/2 of an apple? That's because 5 is exactly half of 10, and the fraction 5 over 10 can be simplified to 1 over 2. That's why having 1.5 apples is the same as having 1.5 apples. Pretty cool, huh?
Having 5/10 of something is the same as having 1/8, 1/5, 1/4, or 1/2. Were you paying attention? Yeah, 1/2.
Anyway, back to counting. 6/10, 7, 8, and 9/10. Now we have one whole apple and also 9/10 of an apple. But our tenths place is maxed out with the digit 9. That's as high as it can count. So what do you think will happen if we add one more tenth? Yep, those 10 tenths combine to form one whole apple, and that will cause our ones place digit to increase to a 2. We now have two whole apples. Even though one is made up from slices, the amount is still equal to one whole. See how decimal digits help us count in between whole amounts? But wait, there's more. More decimal number places, that is. The tenth place allows us to count in between the ones. But what if we want to count amounts that are in between the tenths? The decimal number places keep on going to the right, and each time they count amounts that are 10 times smaller than the previous amount. So, if the tenth place counts fractions that are a tenth of 1, then the next number place over will count amounts that are 1/10 of a tenth. 1/10 of a tenth is called 100th, and it's the fraction you get if you take a tenth and then divide it into 10 equal parts. It's a very small fraction, and it's called a hundredth because it's the same fraction you get if you take a whole and divide it up into 100 parts. So its fraction form looks like this: 1 over 100. Just like tenths could be used to represent amounts that are in between the ones, hundredths can be used to represent amounts that are in between tenths. And just like if you combine 10 tenths, they equal 1. If you combine 10 hundredths, they equal a tenth. And the decimal number places keep on going like that. The next number place over represents fractions that are 1/10 of 100th. That very small fraction is called 1,000th because it would take 1,000 of them to make one whole. And the next place over is 10 times smaller than that. It's called the 10,000th place. And then there's the 100,000th place. There's a millionth place, and so on. So do you see how truly amazing our number system is? It can represent any whole number amount, no matter how big, by adding bigger and bigger number places to the left. But it can also represent amounts in between those whole amounts, with more and more precision, down to the tiniest fraction imaginable, by adding more and more decimal number places to the right. That is truly amazing. In fact, it kind of makes my head hurt just thinking about it. Of course, could be this doggone pot of wearing my head all the time. Okay, so now that you know how decimal places work, let's talk briefly about how we can show their place value and how we can write decimal numbers in expanded form. A digit's value is determined by the place that it's in. So, if a 2 is in the tenths place, it stands for 2/10, which can be written with the fraction 2 over 10. If a 3 is in the tenths place, that stands for 3/10, or 3 over 10. If a 4 is in the tenths place, that stands for 4/10, or 4 over 10, and so on. And just like a 2 in the tenths place stands for the place value 2/10, a 2 in the hundredths place stands for the place value 200ths, and a 2 in the thousandths place stands for the place value 2,000ths. Knowing that will help us write decimal numbers in expanded form, like the one we saw earlier, 126.53. The expanded form of the whole number part is easy. We learned how to do that in the last video. 126 is 100 plus 20 plus 6. But now we need to add the fractions represented by the decimal digits, too. Since there's a 5 in the tenths place, that stands for 5/10. So we need to add the fraction 5 over 10 to our expanded form. But we also have the digit 3 in the hundredths place, which stands for 300ths. So we also need to add the fraction 3 over 100 to our expanded form. All right, so that's a basic intro to decimal number places.
It's real easy. Whatever number you say, you're just going to write that down. So if it's 3/10, you write the 10 on the bottom. If it's 400ths, you write the hundreds on the bottom. So if we have, like this number down here, we have 0.33. Let's use that one. It'll be 33. And then what is this? Tenths. What's after tenths? Hundredths. So you just put hundredths down. So whatever name you say last, that's what you put on the bottom there. Look at zeros. So by inserting a 0 behind the last non-zero digit in the decimal part, it doesn't change the number. So we have 0.33 and 0.330 here. Well, I can add as many zeros as I want to this number. It's still the same number. These two numbers are the same no matter how many zeros I put. Okay? Because the 0 has no value. So when you're doing them in decimals, it'll have no value. So you can put 1,000 zeros there, and it will still be equivalent to 0.33, 33 hundredths. Okay, so look at the place value chart here. So we have 4/10 and 0.40. They're the same thing. So the 4s are in the tenths place. It doesn't matter how many zeros are in the fours. 4/10ths and 40/100ths are equal decimals because you don't need the zeros. So if there's zeros there, as long as there's not another number here after the 0, then these two will be the same because we don't care about zeros that are after your last digit, okay? Fraction tiles, you might want to use them. That'll help you with this. But all these are the same. 1/2, 1/4, and 1/4, which is 2/4. 1, 2, 3, 4, 4, 1/8, which is 4/8. They're all the same. See how they're half of that circle? So you have 1/2 here. It's the same as 0.5. So 0.5 are 5/10ths and 1/2 are the same. 2/4 and a half are the same because 2 is half of 4. Okay? 4/8 is the same as a half because 4 is half of 8. If you had 15/30ths, that's the same as a half because 15 is half of 30. How do we find equivalent fractions when they aren't easy like a half? How do we go about doing that? On a test, you might be given 3/8 equals something 24ths. You have an empty numerator here you need to find out. And so it's got to be equal because it's got the equal signs there. So to find the missing numerator, this is where knowing your times table is going to come in really handy. You ask yourself, how many times does 8 go into 24? Well, 8 times 3 is 24. Okay? Once you find that, you have to multiply the top number by the same thing. So if 8 times 3 is 24, then you need to go 3 times 3, and what does that equal? 9. So 3/8 and 9/24 are equivalent fractions. What if they're mixed numbers? We see this a lot. Look at this one. 11/4 is equal to 2 3/4. Well, to find an equivalent for a mixed number, you have to change the mixed number to an improper fraction. What does that mean? What is an improper fraction? An improper fraction means the bigger number is on top. So the bigger number is in the numerator and the smaller number is in the denominator. It's improper because that's not how we want our fractions to look. We usually want our smaller number on top, big number on bottom. But to find out the equivalence when using mixed numbers, you have to change your mixed number into a improper fraction. But how do we do that? So let's look at our example here. We have 2 3/4. So what you have to do is multiply the whole number by the denominator, okay? And then you add the numerator. So here's the denominator, and this is the whole number. The 2 is the whole number, the 4 is the denominator. So we do 2 times 4. What does that equal? 8. And then we do 8 plus 3. There's a lot of operations going on here. Then we do 8 plus 3, and that equals 11. So the denominator stays the same. You keep that 4, but now the top number is 11. So 11/4 and 2 3/4 are the same thing. Okay, so you multiply here, and then whatever that equals, you add the top number. So multiply, get your answer, and then add the numerator, okay? About these, true or false? 0.5 and 0.50 are equivalent. They're the same thing. Equivalent, means equal. Yeah, because remember what we said? We could put as many zeros as we want. You can look at the 0.5 and 0.5. 5/10 and 5/10 is going to be. Now look at this one. 0.02 and 0.20. Okay, are those the same thing? We can add 1,000 zeros there. What is this one? What do we call that one? Would be color here. 2/100ths. And then this one This one over here would be what? 2/10. Are they the same? No, they are not. Okay, let's look at this. Do you remember how to do these? Rewind the video if you don't. So find the missing number that makes the fractions equivalent. So remember, we have to ask ourselves, 5 times what equals 25? Times will 5 go into 25? 5, 10, 15, 20, 25. 5 times. Okay, so then we have to do 5 times 3. If you don't know your multiplication tables, you really need to learn them, and it'll make your math so much easier and so much faster. 5 times 3 is what? 15. So that should be 15 25ths. What about the bottom one? How many times will 4 go into 36? 4 times what is 36? Did you figure it out? 4 times 9 is 36. And then 3 times 9, you have to because we multiplied the bottom by 9 to get 36, we have to do the same thing to the top. So 9 times 3 is what? Take a second to figure that out. Pause the video if you need to. Don't just keep watching and have me tell you the answer. That won't do you any good. Okay, so 9 times 3 is 27. Okay, which of the following is equivalent to 4 3/8? Do you remember how we figured this out? You have to make this into an improper fraction first. How do we do that? Okay, we got to multiply. What is 4 times 8? So you go 4, you multiply this way. Okay, so you got to multiply that. Okay, did you get an answer? Ooh, that's tiny. 32. And then you add whatever your answer is there to that top number. That is getting crowded. Room there. So 4 times 8 is 32. And then you have to add the top number. And 32 plus 3 is 35. Okay, so we have this one and this one that both have 35 in the answer. So which one is correct? What does the denominator need to be? Yeah, we keep it the same. So 35/8 is the correct answer. So this is the one we want here, 35/8. Good. Okay. Okay, so this one wants us to convert each decimal to a fraction in simplest form. What does simplest form mean? As small as we can get it. Okay. So some of these decimals, it would be worth memorizing what they are. Like 0.75 is a common one. Okay, 0.5, common one. 0.25, common one. So some of those you might need, I would just memorize them because it's going to make life easier. But if you don't know what 0.75 is, 75 hundredths, okay, that's how we need to write it, right? Then you need to figure it out. So we have 75 hundredths. Okay, so that is a fraction, but it needs to be in simplest form. So how do we do that? You need to find what number goes into both the top and the bottom equally. So we know 5 will because this ends in 0 and this ends in 5. 5 is a small number and it's going to take us a while to get this down. But you can do it that way if you want. Think of it like money. Think of this like quarters. Okay, how much is a quarter worth? 25 cents. So can 25 go both into 75 and 100? Yep. So that's the quickest way to do this. How many quarters is 75 cents? 3. How many quarters is $1? 4. See, so think of it in a different way if you need to. That'll help you out. But if you needed to do it in fives, you could do that. How many times will 5 go into 75? It'll be a bunch of times. How many times will 5 go into 100? A bunch of times. And you have to keep breaking it down and keep breaking it down, keep breaking it down until you can't do it anymore. Okay, so if I needed to do it by fives, 75 divided by 5 is 15. 100 divided by 5 is 20. But you can see that these can still go smaller because we can break this down again. How many times will 5 go into 15? 3 times 5 is 15. How many times will 5 go into 20? 4 times. So 3 times 20 is 4. But 0.75 is a really common one. So I would just remember that 0.75 is the same as 3/4. Okay? Makes it real easy for you. 75 hundredths, 0.75 is going to be 3/4 every time. Okay? Next one, how do you write that? Okay? So it'll be 2 over 10. But they're both even numbers, so I know it can go down smaller. So what number will go into both those? Yeah, this one's easy, 2. So 2 will go into 2 how many times? 1 time. 2 will go into 10 how many times? Yeah, 2 times 5 is 10. So 2/10 is the same as 1/5. Okay? Okay, what about this one? So we have 1. Whoa. Sorry about that. So we have 1. Let's do it over here. 1 and 5 what? How would we write that? Tens, yeah. Okay. Can this go down any smaller? Okay, so maybe you remember what we said before about equivalent fractions, what 5/10 was. But if you don't, how do we figure this out? 5 will go into 5. Ooh, thing doesn't want to write. 5 will go into 5 1 time. 5 will go into 10 how many times? 2. Okay, and we just leave the 1 there. Okay, so it's just 1 and 1/2 is the same as 1/5. 1/5. Sorry, that is not right. 1 and 5/10. Ooh, sorry, it's late in the day for me. So 1 and 5/10 is the same as 1 and 1/2. Okay, good. Sorry about that. Here's going to be the hardest part of the whole thing is converting a fraction into a decimal. How do we do that? It's going to take some division. All right.
In the last section, we learned how to convert some special base 10 fractions into decimals, and vice versa. Now we're going to learn how to convert any fraction into a decimal. And it turns out to be really simple. All you have to do is divide. Since a fraction is really just a division problem, if you go ahead and do the division, you'll get an answer. And that answer will be the decimal value of the fraction. Now there's two ways we can do the division. The easy way and the hard way. Now, just because I'm mean, we're going to start with the hard way. Let's take the fraction 1/2 and convert it into a regular division problem with this division symbol. Now all we have to do is follow the procedure for division. We just see how many times this 2 divides into this 1. Uh-oh, it won't divide any times. 2 is bigger than 1. Looks like we're going to need some help. And that's where the decimal point comes in. Now you remember that in the last section, we learned that 1 could be written as 1.0, or 1.00, or 1.000, and its value is still 1. Let's try doing that here and see what happens. After the 1, put a decimal point, and then a 0 in the tens place. Now our division problem looks like 10 divided by 2, and that's easy to do. The only difference is we have a decimal point. let's ignore the decimal point for a minute and pretend that our problem really is 10 divided by 2. So 2 will go into 10 5 times, because 5 times 2 equals 10. And that leaves no remainder. So we're done, right? Not so fast. We've got that decimal point to deal with. And we know that 5 can't be the answer because 5 is bigger than 1/2. We just need to include the decimal point in our answer for it to be correct. We put it directly above the decimal point in our problem. There. Now our answer is 0.5.
And this is where it becomes very important that when you're working these problems out, you keep them all in line. Because if you have that decimal point in the wrong place, it's wrong. So you want to write these neatly as you can, lining everything up when you work these out.
Or 0.5, which is the more proper way to write it. So by dividing, we figured out that the decimal value of 1/2 is 0.5. Now let's try converting a fraction 3/4 by dividing. Of course, we start by rewriting our fraction like this, 3 divided by 4. And again, we run into the same problem. 4 is too big to go into 3, so it looks like we're going to need a decimal point here too. Let's put a decimal point after the 3 and a 0 in the tens place to make 3.0. Now our problem almost looks like 30 divided by 4. Now if you remember your multiplication table, you'll know that 4 goes into 30 7 times, because 7 times 4 is 28. 30 minus 28 leaves a remainder of 2, but we don't want a remainder, so let's keep going. 4 is too big to divide into 2, so the only way we can get rid of the remainder is to use another 0 in the hundredths place, which makes the number we're dividing up kind of look like 300. Now we can bring down that extra 0 to make the remainder look like 20. And 4 will go into 20 5 times, because 5 times 4 equals 20, and that leaves no remainder. Oh yeah. But don't forget, we need to include the decimal point in our answer. Now if you've kept your columns lined up like I have, you'll see that the decimal point goes right here, and that makes our answer 0.75. So the decimal value of 3/4 is 0.75. Alright, let's convert one more the hard way. Let's find the decimal value of 1/3 by dividing 1 by 3. Again, 3 is too big to divide into 1, so we'll need to use a decimal point and another 0, which makes our problem look like 10 divided by 3. That's easy. 3 goes into 10 3 times, because 3 times 3 equals 9, and that leaves a remainder of 1. Just like before, we don't want a remainder, so let's use another 0 so we can keep on dividing. And that gives us 10 divided by 3 again. Well, we know that 3 goes into 10 3 times and leaves a remainder of 1. Huh. Still a remainder of 1. Well, it looks like we're going to need another 0. But that's just going to give us 10 divided by 3 again, which is going to give us another remainder of 1. This looks like it might keep on going forever. Some fractions are like that. If you divide them, you'll see a repeating pattern of numbers that continues on forever. So the decimal value of 1/3 is 0.3333333, and 3's that keep on going forever. But since we can't keep writing 3's forever, we can just stop and round the number off. Or we can use this special symbol that means this number repeats forever. Here they are again so you can review them. 1/4 equals 0.25. 1/3 equals 0.3333. 1/2 equals 0.5. 2/3 equals 0.6666. And 3/4 equals 0.75. So that's how you convert any fraction into a decimal.
Do you have that down? Do you know how to convert each fraction into a decimal now? Let's try 1/4 and 2/4. So 1/4. Convert that into a decimal. This is one of the ones that we said, remember, this is a good one to memorize because you'll see it all the time. So do you remember what it was? If you don't, you need to figure it out. So let's do that. So the denominator is always on the outside here. Then your numerator goes inside. Okay? So 4 can't go into 1, so what do we have to do? We have to make it a decimal. So now it's like 4 going into 10. I always put my decimal up here first so I don't forget. So now 4 will go into 10 how many times? 2. 4 times 2 is what? 8. We have 2 left over. 4 can't go into 2, so we need to put another 0 here. Bring it down to make it 20. Will 4 go into 20 evenly? Gotta know those multiplication tables. If you don't know your multiplication tables, this is going to be so hard. It'll make your life, your school life, a lot easier. Your life. I mean, we use multiplication all the time, even as an adult. So, and it's kind of embarrassing if you don't know your multiplication tables, especially as an adult. So make sure you know these. So 4 times what is 20? 5. So that goes in evenly. So 1/4 is the same as 2. I'm sorry. Whoa. Let's try that again. So 1/4 is the same as 25 hundredths, or 0.25. Make sure you put your decimal there. Okay, what about the next one? 2/4. Well, there's a couple ways to do this. If you know your multiplication tables, you would see right off that 2 is half of 4. So it would be 0.5, because I know that 0.5 is the same as 1/2, which I can't seem to write for some reason. That's a lot of ones. There we go. Okay? But if I didn't know that, how would I figure it out? The denominator goes on the outside. I don't know why I'm having so much trouble with my pen today. 4 can't go into 2, so I've got to put a decimal down. I always bring this decimal up first so I don't forget it. Okay, now I have, looks like 20 divided by 4. So 4 will go into 20 how many times? We just did it. Do you remember? 4 times what is 20? 5. So 2/4 is the same as 5/10, which is the same as 1/2. Make a big giant 1 right there. All right. So does this help? I hope this helps, and that you're able to convert your fractions to decimals, and that you can find the equivalence when you're using mixed fractions, and you know how to simplify mixed fractions. So I think you're going to do great on this.